All right, so quiz 8. Here, again, notice how the base here, and this is a catalyst actually too, it matches the esters. So could this add? It could, but it would get to the same ester you already have. Two esters, the dicarbonyl, right? So the alpha CH is between two carbonyls is acidic. So you deprotonate. You're gonna do a Michael addition. Right, you're gonna do a Michael addition. It's gonna add in there. Right, ways you can kind of start to see this over here, hopefully. So that beta position, make the enolate there. Now, you're gonna need to do an enolate switcheroo, right? Of course, where this takes deprotonates there, makes the enolate there. And why you have to do that is because if it was 1, 2, 3, 4, we don't usually make 4-membered rings in organic chemistry, but we do make 6. So we need to move, right, the enolate to this side. Right? If there's alpha CHs there, we can do that. So then it adds in intramolecularly. Do an elimination. We remake O minus, so this should have been a catalyst, my bad. And that gets you to the final product. Basic conditions, Michael addition, and an enolate switcheroo. So for this one, same product we just started with, but now you're kind of forced to do the addition. So here, OH minus in heat and water, and you see minus CO2, that is the clue that you need to add something in here. There has to be an addition step. So now we're actually going to add in, because we're going to try to get rid of an ester. So if you remember, one of the things we can do is decarboxylation, right? Where if you take an ester in acidic or basic conditions, you can turn it into a carboxylic acid, right? We know that. We did that a bunch of times. So that's what happens here. We add in, eliminate, and then we deprotonate, right? We made the carboxylate. This carboxylate, right, if the carbonyl can make an enolate, it'll just decarboxylate, so the CO2 will leave, like an elimination here. Makes an enolate, right, which is a nucleophile, then can do an SN2, and that gets us to our product. So to review it, what you know is you can take an ester in acidic or basic conditions, and you can turn it into a carboxylic acid. Well, maybe you didn't fully realize, or we saw a couple of times, once you have a carboxylic acid, you can turn it into a carboxylate, like an O minus here, and it can like leave as CO2. And you make, if you can do resonance, if you have something that can do resonance, which this can, right? That negative charge, those electrons can do resonance, you can lose CO2 this way. That's what our bodies do. And then we can do an SN2 if you add something in there, because this is a good nucleophile.